it's Crypto Mux aka Zoid right here, and I am excited about this video. Before I uploaded a similar video, but except I had to take it down because it contained some sensitive information. But first of all, I would like to say a big thanks for clicking on this video and learning with me. And before we get started, don't forget to like, comment and subscribe and smash the notification button to get notified for future videos. Now, let's get started on exploiting reverse proxy prior to traversal vulnerabilities. Now, this is a very big niche at the moment. Everyone is looking for them, but my mistake I made in my last video was I exposed some sensitive information on some bug-bound websites I shouldn't have done. So let's just move on from that. I apologize to the community. Let's move on from that. But first of all, let's have a look at their agenda. So here is the agenda. The first thing we're going to be talking about is what is path traversal. Then we're going to be going on what is a reverse proxy and how do we exploit it, and also a technical demonstration, and that will be the end of the lesson. So what is path traversal? Path traversal is a directory traversal, consists in exploiting insufficient security validation and sanitization of user supplied input in file names such that the characters representing traverse to parent directory are passing through to the file APIs. Now, before we move on to the next agenda or next part of this video, we need to talk about path normalization as well. Now, reverse proxies sometimes fail to normalize the requests, and when the reverse proxy fails to normalize the requests, that's when often the secondary context path traversal vulnerability appears. Let's move on to what is a reverse proxy. Now, what is a reverse proxy? It's simple. In computer networks, a reverse proxy is a type of proxy server that retrieves resources on behalf of a client from one or more servers. These resources are then returned to the client, appearing as if they are originated from the server itself. Now here is a diagram right here. I'm showing how the attack works, or how a reverse proxy works just in general. So we have the client, and his requests get passed through a reverse proxy. Reverse proxies have certain rules that are set on the internal side, and those rules are then applied to the reverse proxy when the requests that are being passed through to the public app. But if we trick this reverse proxy by doing a path traversal, we can access internal apps. We can trick the reverse proxy in accessing internal apps, and that's how the secondary context path traversal works. Now, what are we going to do in exploiting these type of vulnerabilities? Well, first of all, we need to identify an endpoint through spidering or even reading JavaScript. Simple as that. We need to do our recon. So when we find an endpoint, an example, we might have api.example.com/v1/verify token, right? Now we go to this very end path here, right there. I made a mistake. It's meant to be verify token here, so that's my bad. I just made a bit of an issue there, so let's fix that up right there. So we would generally look at this endpoint here. The endpoint is the end path of the URL. We want to fuzz right here. We want to basically traverse back. Now we want to go ... as many times back, and sometimes you might come across a WAF, a web application firewall, that we get a 401. Now, when we get this 400 bad request, when we go ... that generally means we're going too far back to the root directory or the internal root doc. So if we go back one more, and we should get a 404, and then we fuzz right there. So this is where we would fuzz right here. So this explains in detail. So example, we've got api.example.com and this endpoint. We fuzz, okay? So we fuzz right there. We do our path traversals right here at the very end part. So right here. We notice that we go back. We just traverse once. We go ... or ... send-me-some-column / and we might have a word list of all the different types of characters to fuzz. We notice we get a 404 not found. Now this 404 not found is different compared to all the other 404s. We notice some differences in the 404 page. So then we try to we go further back into the directories and we get a 400 bad request. meaning that we've actually done something. We've gotten something good here. So what we're after is, this means 400 bad requests means we are going one directory too fast. So we go back one, and we notice that we go to the internal root directory, so we need a fuzz right there. And we notice that maybe admin exists. We get a 404, so it may exist because sometimes status codes can trick us. So sometimes you might need a fuzz admin and fuzz slash, CSS, or we might need to fuzz more than one endpoint to actually get a successful 200 OK or 302 redirect. So that's pretty much how path traversal or secondary context path traversal works. Now, for a technical demonstration, I'm not going to be showing you any sort of vulnerabilities live out there or any sort of bug bounty program that may contain this vulnerability. Instead, I'm going to be showing you some really useful resources that are very valuable to a hacker to learn this sort of stuff. And this is actually PowerPoint presentations and vulnerabilities found by really good hackers. Let's move on to some resources. Alrighty, so let's have a look at some research. First of all, if we want to get good at these sort of attacks, we need to research this sort of stuff. Best to actually Google it. Don't ask all these hackers some questions and always constantly spam them, because it's not the way you learn. They had taken a long time to get from down the bottom all the way up to the top. So you need to put in that effort at work too. You can't just expect to go to the top straight away. You need to put some effort in yourself. So without further ado, let's get started to learning these resources. Okay, so this research is done by Sam Curry. His handle is ZLZ. He's a web application security researcher, and he was hacking on Starbucks, which is a huge bug bounty program. And I'm going to summarize this blog in smaller chunks and smaller steps. So first of all, he noticed this endpoint, BFF Proxy Orchestra. I'm not sure how to say it, get user, but he noticed BFF. Now, BFF, he would have obviously looked up or contacted hackers, and BFF stands for back for front end. Now, that's basically incense our reverse proxy. What happens is get user will retrieve the user information from the server side and present it to the user. So first of all, he draws a diagram on how this works. So you've got the back for front end proxy that forwards a request into the internal network and obviously internal.starbucks and presents the results to the user. That's how it all works. This diagram is how the attack works. Now, what he noticed, or what he did, right, is he fuzzed with these characters here. Now, it's worth noting these traversal attacks, because these will be very useful for when you actually test out these vulnerabilities. So make sure you note these down, these little dots, these little attacks here. Okay. Next step. All of them return the same 404 page. So, boom, it's not vulnerable. Damn, that sucks. It's not vulnerable. So he had to look for another endpoint that he could use that maybe supplied input and that he could attack. So you notice this one here, which was bff/proxy/stream/me/stream item/stream item ID. Now this one here, this end part here, was user input. So he then traversed back with the payloads he given them, given the endpoint, and he got this .. here that returned a 404 not found, and it was in JSON. Now, it doesn't always have to be in JSON, the 404 page. It can be in HTML, it can be anything. As long as you get that 404 and it's different towards all the others. Then he noticed that he went back one more directory and got a 403 forbidden. So, bloody WAFs, so in the way, they blocked that request, the WAFs blocked it. That's so annoying. So luckily WAFs are pretty bad at filtering out stuff. So he did like a .. and then just a .. And what that .. did is returned the same 404 page. So now he needed to get that 400 bad request. So he traversed 7 paths back, and boom, he got a 400 bad request. So he knows that it's 7 paths back. Actually, and then you go back forward again. So 7 paths back to the 400 bad request, back one more. So it's a total of 6 paths to get to the internal API. But now we need to exploit this. That's just basically the proving that we've actually caused the reverse proxy to fail and give us back that 404. And we've actually accessed internal API, but now we need to be able to look at it and see what it gives us. So first we need to find an endpoint. So He fuzzed it, so he fuzzed an endpoint and got a 301 when he typed in /search. Now, he noticed that that 301 provided for all the files that existed. So he reached out to another hacker named Ryan Raider, and he is an awesome hacker. He looked into this and he found out /search, /v1, /accounts belong to a Microsoft Graph instance. And this is when the fun stuff begins. So he noticed by traversing back, he could view all the accounts of all the hundreds of millions of users, and that was a very bad bug. He could do a lot of different stuff. He could view that API, that internal API, and access all the users. Very, very bad. That gave him a $4,000 bounty. Just like that. Brilliant, isn't it, guys? Brilliant. Now, this next part is going to be about how you do secondary context in web applications, how you attack them. So this was presented by ZLZ, same hacker I talked about before, and he explains secondary context in detail. So he talks about previously thought, so what people thought HTTP servers were, and how they worked, but now there's more things to do with routing now, routing, and then he looked at different ways applications do routing. Now here are the reverse proxy rules. So proxy pass, as you can see here, they're pretty explanatory. They're pretty self-explanatory. So location, anything with some path will pass to this proxy here. So this tells you the location of what is allowed to go pass through. These are rules to do with reverse proxies. So anything with /images will get passed through to example.com. These are how it works, but we are completely blind with these. We need to figure out what, if we looked at these directly in the internal side, we can work out what we can do straight away. We're completely blind with these. We need to work out these in our heads. That's why we do those .. Get the 400 bad request, boom, 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 go back 404. That's how we do it. So let's have a look at different ways web applications do routing. And this is his same example. So profile ID equals 1 will send off to the server side, internal example.com, and that would be presented with, the user would be presented with the name Sam. Next thing is different characters to perform fuzzing techniques. So fuzzing user control characters. These are the characters he uses for fuzzing to find those errors that he needs. And then there's lots of different stuff. There's lots and lots of very valuable useful information on secondary context path traversal. And then what he does is he explains some attacks that he's found or vulnerabilities he's found on actual live applications that are already fixed. So you notice that this one right here, he identifies the application routing. That's the first thing he identifies. You identify the routing. He just typed the %23, which was the hash, and it caused the application to fail to read the file, meaning that the reverse proxy has failed to process that request. Then he moved on to doing %2f, %2f33. So that's a .. and it's a hash at the end. Again, it was unable to read the file, and as you can see, it got reflected in the JSON response. Then he noticed by doing a .. and then his the victim's ID of the account, and then so actually it was .. the victim's ID, and then another / and then plus the victim's file. In this sort of format right here, he's able to view the victim's image, which is another sort of path traversal technique. Probably less impactful, but if this was more to do with email, the profile's information, then that would be very impactful. Very, very bad. And this one is another interesting one. He noticed that Luminate it contained an endpoint, my services, invoices, and then the invoice ID, and then the PDF. So what happens is you could download a PDF and be presented to the screen the PDF. Simple. But he's a hacker. We're hackers. We want to abuse this somehow. So what he did is he tried to traverse back, use some techniques to traverse back, but instead of .. victim's ID and / the image, he did the same thing, but instead he put / and then the invoice. So he did .. invoices / and then the invoice ID. But how do we get these informations? That's the hardest part. How do we get the invoice number? How do we get this information? Well, he was actually he actually did this part traversal right here and got a 200 OK, meaning he was able to access that invoice, but then he wanted to access without PDF content. So he got a 44. Perfect. Next thing, this doesn't really do anything. This doesn't really prove anything. So, but it's something interesting. So let's move on to the next one when he tries to exploit this in a more clever way. So what he did is he noticed that there was a user ID, invoices user ID. Why can't I say ID? I say ID. ID I meant. Okay, that was a very silly joke, I must admit. So he noticed by all he needed was the invoice ID and the user ID, and he could access anyone's invoice, which has some impact to it. So he had to guess the directories. He had to guess what the other users' invoices are. So again, moving forward, he noticed this little pattern here. He could do a ... the email, not the victim's ID, the email, and then a slash, and then a VJ, a slash invoices, slash, and then the invoice ID, or the invoice code, or whatever they call it, and then he was able to access everyone's invoices. That's very impactful. But here's to how we went wrong. He fuzzed, I think that's about a million IDs, and that didn't give us nothing. He didn't give nothing back. But he noticed that the email address was exposed, and that's what he got in clicking in his head, that he needed to use the email. And then the magic begins. He was able to view that invoice. Obviously, he can't use other people's invoices because that would be against the bug bounty rules. But he just viewed his own invoices in his party vessel. He could have viewed anyone's email addresses, but they needed to know the email address and invoice number. That's an alright bug, hey? Well, I guess isn't it behavior? This is not normal behavior. This is not how the web application should work. But this is a cool bug. I love it. This PowerPoint goes over many different types of sector context examples. It's worth a read. I will put it in the description so you can read it later. Moving on to reverse proxies inconsistency. Woo! So here is another cool PDF write-up on reverse proxies and inconsistency. Now this is about how we can abuse reverse proxies. So let's have a look about this. Again, it tells you the author, it tells you who made this presentation, and it tells you what a load balancer, what a reverse proxy and cache proxies are, which we discovered earlier, and some basic techniques to abuse the reverse proxy. And it tells you some of the stuff is. A long path here. It tells you how the paths work. So these are some Euro encoding techniques that can abuse proxies. And here's what path normalization is. This is very useful. So if we have a look at this part here and the // path here, it's basically gone back a directory. So it will just be path here. If we do // it's the same as just doing the same slash. It's the same as going along path here. These are what these relate to. So if we do a long / path here, that would be equal to the same, exactly the same, or just a single slash there. If we do long path, so long /path / here, then .. that's equal to going back a directory, or it's just the same. And different types of reverse proxies like Nginx, they have different sorts of ways they normalize the requests. And this is kind of what this is all about. Again, this will be in the description below so you can have a look at later. But now let's look at what types of reverse proxies and how they process the requests. And this is on GitHub. This GitHub page talks about weird proxies. And these are all the different weird proxies that we can have a look at. And by the way, the reverse proxy should be shown in the response of the web application you're testing. So for example, Nginx can process requests like this. So if you have, they obviously have case sensitive for verb 400 error. 400 error means we've identified some routing. Doesn't treat / as a directory. It will just go, if you do the .. // it will go, it will just treat it, it won't treat it as a directory. It doesn't allow in the %00 in a path. It basically tells you what all these mean for different types of proxies. Obviously to fingerprint it, we need to get that 400 bad request. Sometimes you might get that the 403, which has a firewall, so we need to look for bypasses. These are generally how the proxy passes requests. This is the rewrite, and different types of caching detections. This will also be in the description as well. Let's have a look at one more type of proxy. Another one we're going to look at is actually we'll look at Apache. Another one we're going to look at is Apache, because Apache is pretty common. Apache a get is not equal to a capital get. It treats /s as a directory this time, so it's the complete opposite as Nginx. And these are all the basics of how the Apache processes requests. Fingerprint obviously is a 400 error. That's how you detect if you've got a successful route. 403 is sometimes WAFs getting in the way. We need to find bypasses. So again, these are all the different types of things for Apache reverse proxy. Very useful information there. So back to the PowerPoint presentation. I think we are almost done here. But first of all, I would love to say a big thank you for watching this video, and being a big part of the community. And all it takes is time. If you're struggling finding bugs, it takes time. You know, my first bug took me almost 6 months to a year. It's not that hard. It's not that easy to find bugs. There is so many great hackers out there, so much professionals that are finding these big bugs, and it can put you down. You can feel shit. You can feel quite disheartened because they're finding bugs and you're not. Well, do you know what? We've all been through that, and that's called imposter syndrome. It's the main thing you need to do is not think about others, think about yourself, and keep learning. Do bug bounty as a fun thing to do. Don't rely on it as a source of income. Don't be disappointed if you can't find bugs. It's a part of life. It's part of what everyone is doing at the moment. They're always struggling and finding bugs. Lots of people are struggling to find bugs, even the top hackers. Now, if you are not getting proper payment from this and not finding bugs, it's worth to get a job in pen testing or web pen testing to get an actual income. Or it's best just to move on and find something else you like doing. But bug bounties is very inconsistent. You shouldn't be relying on that as a source of income, okay? Another thing is, don't just focus on one bug. And first of all, you need to learn the whole bug classes. This is one important thing that will help you find bugs. You need to learn all the vulnerability classes, because you may skip a lot of vulnerabilities if you only learn, say, cross-site scripting. You may look at a request, it might have a cross-site scripting vulnerability, but it may have cause. So just knowing cross-site scripting, you may just report that and get $500. But if you know cause, and that's in the same request, you can chain that with an account takeover. And that will be in future videos as well. But it's best to know all the vulnerability classes and mix them together. Like, for example, don't just report open redirects, because they can be chained with so many different bugs. I do not like it. I find it quite selfish when people report open redirects, because other hackers are trying to chain those open redirects with other tools. Think of open redirect as a tool, and plus it's not impactful. You might need to get $100. You need to chain it with something like SSRF or OL2 takeovers, then you'll get the big money. You get $1,000. You almost triple the bounty, okay? So again, thank you so much. I love you all. Thank you for watching this video, and I will see you later in upcoming videos. Have a good day, happy hunting, and use the legends.